Hey everyone, and welcome back. Long time ago, I made a video about Wails, which is a framework or a library to build desktop cross-platform applications in Go. And recently, I had to revisit this project, and the reason being is that I wanted to develop the two-factor authenticator client for myself to play with that, and I thought that the Wails is a good candidate to use for this project. Back then, I used the version 1 or 2, I believe. Nowadays, the version 3 is on its way, but not yet released. And so the goal of today's video will be to build the two-factor authenticator client in Go using Wails. Think of it as similar to Google Authenticator application or Microsoft Authenticator and many others. And also we'll explore how 2FA works under the hood and understand the algorithm. Let's start with a short recap of what Wails is. As I already mentioned, it's a library to build desktop applications in Go. It's not Electron. It's kind of similar, maybe. It's more lightweight and more fast. Then you use Go on the backend. You compile it to kind of TypeScript models. You can see how it works here, right? You develop your structs in Go. They're available as bindings or through bindings in JavaScript code. On the front-end side, you can use technologies like vue.js, React. I'm not sure. Somewhere here, there is a full list. I always use Vue with TypeScript, but you can choose something else. Yeah, and you can actually build quite nice applications using this library. Beautiful, lightweight. You build it into a single binary and can distribute it this way. Yeah, I won't go into much more details. You can read it on the website and try it for yourself. And just so you have an idea of what we are going to build in this video is the short demo. It's an application that's running natively on my Mac, very similar to Google Authenticator and others. We have the list of codes, it's fully local, and so forth. So yeah, let's start from scratch, right? Could we wipe code something like that with some AI assistance in under an hour? Probably yes. Would we learn something about how 2FA works, how Wails project works? Definitely no. So yeah, let's learn properly, piece by piece. That's the way of this channel, right? Let's get started. We can start with understanding of how 2FA works under the hood. Most tutorials skip this step completely and import some library, and here we go. But we want to actually understand that. So the first thing that happens is your server, or could it be, let's say, GitHub or Google, they generate a secret. Usually the secret is shared, as you've probably seen, via QR code. So behind this QR code, there is a secret. It usually, maybe not usually, always comes in base 32 format. It's also stripped, so the equal signs at the end are removed, so it's a little bit shorter. It's always uppercase. Now, this secret is shared with the client only once, ideally. And so client has the same secret, right? So client has the same secret. It is only once via QR code, then QR code is usually not shown for the second time. You have to generate a new one. So now we know that client and server, they share this secret. Client can store it in the database, maybe in the file, doesn't matter. The server doesn't know about that. Apart from this secret, they share something else. They share the time, assuming that we are living by the same clock. So in TOTP, T stands, or the first T stands for time-based. So it's time-based one-time password. So based on this secret and the current time, we generate some hash. And by comparing this hash between server and the client, we can assume that the client's secret is correct and we can proceed. Obviously, each millisecond or nanosecond, this computation will be different. So this works in so-called phases or intervals, 30 seconds intervals. As you've seen in the applications, this code refreshes every 30 seconds usually. And based on this counter, we generate the hash. And so let's say we have a current time, which is a Unix timestamp in seconds. It's an integer, let's say a number like that. We divide it by 30, and we get some counter, right? So let's say some counter equals another integer. And so this counter increments by 1 each 30 seconds. Right? So why 30 seconds? I think it's just because it's a good balance. It's hard to guess. And also people, don't have to quickly type their code, so there is some enough time for them to enter this code. This counter is not yet the OTP code that we enter, so just to be clear. After we get this counter, we have a secret and we generate some hash based on these two numbers. Usually, the algorithm is HMAC SHA-1, though SHA-1 part can be changed. So the server can say, I'm using another algorithm, but SHA-1 is the most popular one here. And so if we use our secret as a secret key for HMAC and counter as a value, we'll end up with some 20-byte hash. Now, obviously, the hash is quite long, so for people it will be hard to enter it. Now we need to get a number from this hash, right? Could be 6 digits number, could be 7, usually 6, as you've probably seen. And here's the nice algorithm is used. It's called dynamic truncating, because we cannot just take, let's say, the last 6 bytes and convert them to numbers. It will be very guessable. Dynamic truncating defines kind of this number based on the hash. And there is a specific formula how it does so. Let's say we have a hash like this. We take the last byte, which is 5a, and get the last 4 bits and convert it to integers. So in this case, I know it will be 10 as integer. So we'll use this offset to get 4 bytes based on this offset in this hash. So that would be these 4 bytes, and then we use big endian and convert it to an integer. And then finally, we will have integer, and then sometimes we need to truncate it to the 6. And here will be our final OTP that we can kind of submit to the application. The server will do absolutely the same computation and compare if these numbers are exact. I also want to make a comment about how this secret is shared, because we all mentioned that it's QR code. Basically, QR code contains the link in this format. So this scheme is OTP auth. TOTP, then usually comes the label. This is optional, but that's what's shown in your Google Authenticator application as a label. The only mandatory thing is this secret, which is base 32. That has to stay really secret. You shouldn't share it with anyone, because only knowing this secret, we can generate the OTP code. And there are some other optional parameters like issuer. There could be also the algorithm, I believe, to change. Now, knowing a bit of theory, let's start building our app. If we go to installation, I wish this would be more visible and somewhere in kind of code place like that, but all right. Let's install it. And then let's init the project. Probably in creating the project, as you can see here what I meant, there are multiple frontends that we could use. I'll be using Vue, and I will be using it with the TypeScript. So I can just do, all right, -n, name, MFA client, type Vue TypeScript. Let's go. Cool. Now we can go to our folder and start exploring. And so here's our generated project. It has some files already. So Go files in the root folder. I'll open them briefly. Just let's go through the structure first. So app go, main.go. We have our Vue frontend, so with components app.vue, and some build folder, I guess, with executables, favicons, and the rest. So I like it quite simple, just few files that we need to modify. Right, let's have a look at the main first. We embed some assets. That makes sense, probably some images and videos. Then we create the instance. Also, I think a few things we can configure here, maybe just to verify we pass the assets here, some background color. Something happens on the startup, so we'll review that later. And then it's very important, the bindings actually happen right here, so we can expose our Go methods and structs and so forth. And yeah, so it's quite simple. Now let's have a look at the app.go file. So here we'll do a lot of changes, I believe. Right, so we initialize our struct as context in it. On startup, we will do something, I believe, at least load some accounts that we have. And this is actually exposed. So if you see, There's a greet method currently in the demo, and Frontend probably calls it in app.vue. It doesn't, then it's in the components. Right, so you see how it works on the frontend side. On the frontend, I'll install the dependencies so we'll get rid of these errors. But on the front end, we can import the bindings that are already built and use them in our code base. Let's actually try to run this app as is. There is a command Wails dev. We can do actually Wails build as well. It will build the binaries. All right, as I can already see, the errors are gone. I believe the binary will be somewhere in the build. I guess somewhere here. I don't need it locally. I can just run Wails dev, and it will compile everything. The hot reload will be enabled, so I can do changes both in the backend and frontend. You can see we have a nice app here, and that's, I guess, where the greet method is used, right? So we actually call our Go code from Vue. That's cool. That's the demo that they provide. We can exit. For this demo purpose, I will clean everything up a little bit. I'll remove this component, so I'll just do everything in the app.vue. But we will come back to that a bit later. Let's start with our application. And actually, before even the application, I want to start with the pure TOTP 2FA logic. So I'll create the file totp.go in this folder with our, I believe it's package main, not MFA client. And I imagine that our TOTP.go file will have a generate TOTP based on the secret, which is string, and it will return us, let's say, string as the code, maybe integer as the time remaining, and error just in case. So as you remember, the final counter or the final code is actually based on the secret and the time counter. So we need to calculate this time counter first. We'll do it, we'll get the time now, and let's say the counter will have a function, right? Get counter, and we will do the following. We will return, we'll convert now Unix, and we'll define it by 30. So we have the counter. Now we need to use hmag SHA-1 or any other algorithm and get the hash. So let's call somewhere from here hash error. We'll be, let's say, calculate hash. We pass the secret there, and we pass the counter. As I mentioned previously, the secret is shared in base 32 format, and also this algorithm expects it to be cleaned in a certain way, because the secret is shared usually via the URL, so the equal signs are removed at the end. It's always uppercase, so we need to do some cleanup, because let's say I have some so basically generate some random hex, and then go base 32. As you can see, it has some padding at the end because base 32 works, I think, by chunks of 5. And so it fills the missing probably with equal signs. So we need to get rid of that, also make it uppercase. So our calculate hash actually will do some cleanup. Awesome, so we got our secret cleaned up a little bit. And because it was base 32 encoded, we decoded back. We do key. I'm not sure if it returns an error or not. Is there base 32? Let me see. Right, is std encoding, then with padding to base 32, no padding, and decode string secret. Now we need to generate the hmag, but also before that, we have a counter and we have to format a little bit it to a big endian. We can define a buffer of size 8 and then do, I think it's binary package.bigendian.write or boot. So we have u unsigned integer 64 and we put our counter there. So we transform the counter a little bit, and now we can safely use it in hmag. So I believe it's .new. Then we say which algorithms. So we'll use h1 .new. So here's actually could depend on the input. For simplicity, we'll just use SHA-1 all the time, and then we pass our key. And we write into this guy, we write our buffer, which is a counter, and then we return age dot sum. Then we need to pass new. Not enough, right? So there is no error here. Not enough arguments into the big endian, right? Because we need to make it to the buffer. Or is it vice versa? Let me check quickly. Right, so it's cool. So now we come back a little bit here. So we calculate the hash. As you remember, we need to get the actual code by truncating this hash into the 6 digits. We'll have another function for that. And that will be our final code. Will be, let's say, truncate hash. Now, this function may look a little bit hacky, and it was so to me at first, but there is actually nothing crazy here. So what we need to do, as you remember, we need to get the offset. This one is easy. So we get the last element, and now we need to do some byte manipulation. I think 0x, 0f. And so now using this offset, we get 4 bytes, as you remember. So we always we do some bit manipulation with each one. So we get hash of offset. We need to remove the negative number. So it's 0x7f. We shift 24. Now we come to the second byte. So that will be also hash from offset now, I believe here, +1. Nothing to do here. I believe it's 16, and then do the same for 2 remaining ones. Offset now +2. Then we need to shift 8, and the last one is without shifting. This is a smart way to get an integer from 4 bytes. Let me just confirm everything. Right, so that's the return code. I believe that's it. It compiles, that's good. We get our code. Now I also wanted to return the time remaining, so let me calculate the time remaining. That's good for the user to know. Because we always work in this window, so I can use again our now Unix, and then we get a reminder that, and we return actually code. I want it to be string, so let's do printf. Maybe code time remaining nil. Cool, and that's 62 lines of the very basic TOTP calculation. As you've seen, we haven't used any external packages, just Go standard library, the best standard library out there, as you probably already know. Some functions, we calling these from our application by knowing this secret. Let's do now the storage part. And here we can do different things, right? We could use SQLite, maybe you can store some remote database. I want to be just local first. I'll just be saving everything into the file and putting it into the local directory. For that, I want to also separate it a little bit. So let's do just storage here. We'll do package main. Maybe define it as a type. Store as a struct. And then we'll do file path where to store it. I'll do JSON for simplicity. We'll have some functions on this storage. And let's see, we'll get accounts. Right. We need to define the account first. Account will have an ID. Let me put some JSON tags here as well. ID. Then what else do we have? Issuer. I won't create all, just maybe the main ones. Let me just define the placeholders for all of these functions first, so you can see how it may look like. So we need to add account, an error, and what else we may need? We may need to be able to right, so we'll remove delete account. We can also some internal functions, I believe, like um, save, maybe accounts, an error, because after each operation we'll be doing save. And actually, yeah, we can start by implementing the save. We can do data error JSON Marshall accounts. Otherwise, yeah, we can just do write file storage file path. Now I understand that paste like should be part of our product. Now we get access to the file path. We also pass the data and permission mode. Cool. So we are able to save accounts. We can use it in, let's say, let's start with add account. Interesting part is that I didn't generate any ID and we will need it later. So I'll do ID. I'll call some function that will generate some random ID. Let me develop it quickly. Generate ID, just return some string. All right, so we get some very simple random stuff. Okay, now we can create an account. Let's list them now. All right, so we can get accounts, we can create one, and what's left for us is to delete. To delete, we do very similar as add. First we get, and then we'll just filter, right? So we'll just filter it. Awesome, and that's our storage function into the JSON file. Now I believe we have everything to hook up to our Wails application in terms of backend logic. So we'll go into the app.go and we'll need to expose these as bindings. The first thing I'll change is actually I'll add the storage into our application. And when we do, so I'm not sure what's the difference between kind of this new app or here, where should I define it? But I'll do a.storage. We'll need to initialize one and also put the file path. Just for simplicity, I'll do accounts.json for that. I can completely remove this one, or actually replace it with something else. Again, I'll call the same functions add account. You'll pass from the frontend something like issuer and a secret, and we'll return an error. Now here's the interesting part. Here we'll need to, okay, I'll write account first, but in the database we don't have the codes, so we need to generate the codes. I can create a new type that I will expose to our Vue application. I will do type account with code. It will be a composite type, so it will have account plus it will have a code. Was it a string? It was a string, and then it was time remaining as int. I think it's important to put JSON tags everywhere because the bindings in the view will depend on that. Then time, I'll do lowercase and underscore. And then get accounts will actually account with code. Let's do the following. Accounts error will be app.storage.getAccounts. Otherwise, we can create a result. We can make a slice of counts and then lens that. We'll do 4. And here we'll call our function. We'll get the, what do we get here? Code, time, remaining, and error from the function generate TOTP, where we pass only the secret from our account. And all right, let's handle the error here quickly. Otherwise, we can do the following. Right, count with code. So count, how we type it? I think it's that, right? On with formatting, we'll fix it. Result, yeah, return result. All right, we can get the accounts now. To add, it's actually quite easy. We can do new account, and then we pass everything except ID, because as you remember, ID is generated there on the fly. So we pass issuer as issuer, and then secret. It just returns an error. Cool. So return app.storage. Awesome. And then I believe, right, first of all, this will be delete account. We get just an ID, a string, returns an error. So very similar. I believe just one line, or like return a dot storage. Cool. Now we have our Wails bindings, right? So are actually exposed, and I will show you now in a second. So let's go. If nothing is broken, we can build it. These are okay. This is just view errors because I removed them, but the bindings should be created. I believe we can go to Wails.js, go. So we can look at the models. Right, so in the models, as you can see, there is this class exported, account with code. So this Wails was able to get our Go struct and create a class from that. In the main, I believe we'll have the functions, right? So as you can see, add account, delete account, get accounts there in the TS and JS versions. And these we can call, and they will actually execute the code that we wrote in Go. Now we can go safely. I think that's it from the Go part, and we can go to Vue. Let me put some styles first. And so I already have this Vue app, Vue component written, so I don't want to code it live, but let's go through that and quickly review. As you've seen, similar to before, like first of all, just regular Vue methods like ref, etc., they're all available, which is really great. So it's not that different from developing a web application in Vue. But these bindings from Go, get accounts, add account, delete account. In our case, they're very simple. They just work with files. They call some TOTP logic. But it could be much more complex, right? Could call some APIs and so forth. And yeah, just our regular Vue code with some data, with some method, computed properties. What else do we have here? Mounted, unmounted. We have an interval by which we just load accounts each second, just refresh the page, and just our regular HTML with the list of accounts, with the ability to add one and delete one. Cool. So hopefully we have everything. I believe now we can build it and actually see if that all works. Now we can test our application. It's obviously only a client, so we'll need a server. I don't want to use sample like Google or GitHub to expose it, though I want to use this application afterwards. For that, I need to have some encryption and not use files, but that's not the point of this video. There is the app called totp.app, which we can use to confirm that everything works. But first, let's actually confirm that the build passes. Build. And yeah, so here's the binary that we can use if we want. that we can simply run with Wails.dev, Wails dev. Now let's add some account. And I'll open this TOTP program, and to get a secret key, we can generate some, right? So we can do OpenSSL again, as I always do. Ideally, they cut these things at the end because they should. I can also remove them, but hopefully that's fine. We'll do up one and add, and there is some temporary code, as you can see, being generated. There is a progress bar because it refreshes every 30 seconds. Let's use now the same secret in our Shiny local client. So we also call it up1. We put the same secret key. Now we have the code. Let me open two and see if they match. Yeah, they match. As you can see, they refresh approximately at the same time because, again, they share the clock and we share the same secret. Imagine this is what's in the browser is the server, and my client is going on here. Obviously, they just share the same algorithm. They truncate into the same code. Yeah, and they share this secret. Another way to verify that it works locally is to launch some authentication server locally. The one that I worked a lot previously is Keycloak. And Keycloak we can run locally with the Docker. So let's do that. Okay, our Keycloak is running. We can go to localhost 8080 and log in with our default username and password, and we should enable OTP here if it's required, and white OTP form. Then we can log out, log in again with our admin. And now, as you can see, they give us the QR code option. Good applications also give us an option to set up it manually, because maybe I use different application that doesn't support QR codes and so ever. Here's the code. It's actually also base 32. The kind of extra characters are removed and they added the spaces, so it just looks nice, but it's base 32. And they also tell you the algorithm that's being used, how many digits and so forth. So this all matches what we have in our implementation as well. So we can get this code, put it into our Shiny application, Keycloak, copy it, and then hopefully it works. Cool, and we are in. By the way, Keycloak is quite a good application if you want to have a proper authentication with single sign-on, with different policies and templates and so forth. It's fully open source. I'm not affiliated, just saying, because I use it on one of my projects. There are probably a lot of things we could improve in this application. We can encrypt the accounts. We could save them into some database locally or remotely. We can make the UI better, and yeah, we can build it for other architectures. And that's everything that I plan to do with this app, and see how it works, and maybe let you know if I can completely switch from Google Authenticator to something of my own, though it's not really necessary. But yeah, it's a nice app out there, and now we understand how 2FA works. As you can see, there is nothing difficult out there. And yeah, thanks for watching, and see you later. Bye.